Welcome to Numbers and Operations, Part 3. In this lesson, we will talk about the real numbers and the order of mathematical operations. So let's start. The set of real numbers, and we refer to this set by the letter R. This set includes the set of rational numbers and the set of irrational numbers. So in the previous lessons, we talked about the natural numbers, the integers, and the rational numbers. And the set of the rational numbers was the biggest, and it includes the set of integers and the set of natural numbers. Now, let's see what kind of numbers that might belong to the set of real numbers, which don't belong to the set of rational numbers, which we represented by Q. So an irrational number has decimal places that go on forever and do not repeat in a pattern. So for example, we have P, which is the ratio of the circumference of a circle to its diameter. And we can see that it's approximated by 3.14. However, it's an infinite decimal, so it doesn't end. We take another example. Euler's number is approximated by 2.71, the square root of 3, and phi, which is the golden ratio. So if we wanted to represent now all the sets we have studied till the moment, we can see that the smallest one is the set of natural numbers, which is n, and this includes the numbers 0, 1, 2, 3, and this set goes to infinity. This set of numbers is included in the set of integers. As an example of a number that belongs to this set of integers but doesn't belong to natural numbers is -3. And all the negative integers also don't belong to n, but they belong to z or to z. Now, the set of integers itself, z, is included in the set of rationals that we refer to by Q. And as examples of numbers that might belong to Q and don't belong to Z are -2.5, it's a negative finite decimal, 2 thirds, which is written in the form A over B, while A and B are integers and B doesn't equal 0. This doesn't belong to the set of integers. Also, the recurring decimals, for example, 0.3, while 3 is repeating, which could be written as 1/3, as we proved earlier in our previous lessons. And now the set of Q itself is, which we call the rational numbers, is included in the set of real numbers. So the numbers that belong to the set are the real numbers, which don't belong to the set Q, are the infinite decimals. For example, P and the square root of 3, the Euler number, representing irrational numbers on the number line. Although we cannot exactly spot the irrational number of the number line on the number line because we don't know its exact value, yet we can know where it approximately falls and whether it's closer to the previous or to the next integer on the number line. So let's take an example, P. Which we know is approximated by 3.14. Now we look at the first number of the decimal part. Here we have 1. and we see if this number is larger than 5, smaller than 5, or equal to 5. In this case, we have 1, so it's smaller than 5, so we take the second case. If the first number of the decimal part is smaller than 5, the red mark by which we specify the location of the irrational number on the number line shall be closer to the whole number part of the irrational number. The whole number part of the irrational number in this case is 3. So since we have 1 here, it means that the red mark shall be closer to 3 than to 4 in the case of P. So it shall fall somewhere here. If we say that this is the middle distance between the middle of distance between 3 and 4, so P shall be located somewhere here in this part. In order to specify that in a better way or more precisely, we look at P this way. For example, this means 10 out of 100 or 1 out of 10. If we ignore the 4, 1 out of 10. So it's like if we divided this distance between 3 and 4 into 10 equal parts, then P is approximately located at the first part. Of course, this is not 100% correct, because as we said that P doesn't have an exact value because it's an infinite decimal, yet it's the best approximation we can get for it if we wanted to represent it on the number line. Now, let's take another case, for example, E, which we found the Euler number we found on the previous slide. It's approximated by 2.71. In this case, if we took the first part of the decimal part, which is 7, we find that 7 is larger than 5, so we take the first case. If the first number of the decimal part is larger than 5, the red mark shall be farther away from the whole number part of the irrational number. So the whole number part of the irrational number is 2. And since we have 7 here larger than 5, then the red mark related to the Euler's number shall be closer to 3 than it is to 2. So it shall fall somewhere in the upper half. Okay, and to specify it better, if we ignored 1 and viewed it as 2.7 or 70, then if we divided that part between 2 and 3 into 10 parts, and we counted 7 steps from 2, then Euler's number must be located somewhere here. Okay, and so on. So now, after we have introduced the real numbers and how to represent them on the number line, we move to talk about the numerical expressions. A numerical expression is a mathematical combination of numbers, operations on them, and brackets or parentheses, etc., or other symbols that are used for grouping. And this expression has a unique value. For example, we have now this expression, 2 plus 3 multiplied by 2 to the power of 4 divided by, between brackets, 2 plus 45. So in the following, we are going to learn how to evaluate such kind of expressions. Do we sum first? Do we divide? Or do we calculate the value between the brackets? Let's take a real life example. If we buy 2 books, each costs $10, and a $1 pencil that costs $2. So in order to calculate the total price with a simple mental calculation, it immediately comes to our mind that we have two books, each of them costs $10. So the price of the two books is 2 multiplied by 10. So we work this out and we find that it is $20. And then we do nothing but adding the value of the pen that costs $2. So we can write it this way. 2 multiplied by 10 plus 2, which is equal. So we multiply first, and we know that this equals 20. 20 plus 2 gives us $22. Now, if we give this expression to someone who has no idea about numerical expressions, so he or how to calculate them and find their values, so they might do it in one of the two ways. Either they will multiply first and then add to get the same answer that we got, or they will add first, then multiply. And in this case, if they added first, they will get here 12. 12 multiplied by 2, it will give them 24, which is a wrong answer, of course, in our case. So how can we find a way while if I give this expression to any person, they will know for sure that my intention is to perform the multiplication first and then to add. For this reason, mathematicians have agreed on certain set of rules that is applied on numerical expressions, and these rules prioritize operations. For example, the multiplication is always done before addition in numerical expressions. So if we have two successive operations, multiplication and then addition, then multiplication is done first. And even if we have expressions like that, so addition is coming first, we also multiply. So the value of this expression will be 10 multiplied by 3. This will give us 30. And then we add the 2 and get 32. Let's see this common set of rules and then take some exercises on some numerical expressions to test our understanding. So always when it comes to numerical expressions and valuing them, the operations between parentheses are always done first, followed by the exponents, and then the multiplication and division. We perform this from left to right in case we have successive operations, like let's say 2 multiplied by 3 divided by 6, or for example 6 divided by 3 multiplied by 2. So we always perform first the operations that comes on the left, then the operation that comes on the right. And finally, we do the addition and subtraction from left to right. Let's take an example. This numerical expression between brackets 2 plus 5 to the power of 2. Then we close the bracket and we add 5 divided by 2 multiplied by 4 minus 10. So according to the previous set of rules, we have to do the operations inside the brackets first. So we look into the bracket to find 2 plus 5 to the power of 2. So what do you do first, the exponents or the addition? We notice that the exponents precedes the addition on the set of rules. So we do it first. 5 to the power of 2 equals 25. We still have operations between the brackets. So in order to get rid out of the brackets, we add 2 to 25 to get 27. And the rest stays as it is. Now we have this numerical expression. So we have first addition, then division, then multiplication, and then subtraction. According to the set of rules, we have to do the multiplication and division before the addition and subtraction. And here we have successive operations, like multiplication followed by, division followed by multiplication. And according to the rules, we have to do first the operations that comes first, or to do the calculation from left to right. So we divide first 5 by 2 to get 2.5, and this is to be multiplied by 4, and the rest stays as it is. Now we are at this level. We have addition, multiplication, and subtraction. So we do the multiplication first to get 2.5 multiplied by 4 gives us 10. And now we have addition and subtraction. We do the calculation from left to right. So 27 plus 10, 37 minus 10 gives us 27. So this is the unique value of this expression. Let's do a test now. Write the mathematical expression that models this case. I work in a sweet shop and I have 6 candies to sell in return for 18 euros. Okay, here we have 18 euros. After a month, I sold each candy with 1 euro less than the original price, because sometimes when you keep the food products for some time, they lose their value. They lose their taste, they lose some of the ingredients they contain, they change. So I bought the 6 candies first with 18 euros, and after a month, I sold each candy with 1 euro less than the original price. How much money I got in return when I sold them after a month? So in this case, if we wanted to write a numerical expression that represents this story, we can think first of the price of each candy, and this price would be 18 divided by 6. Now, after 1 month, each candy lost 1 euro from its previous price. It means this is the previous price of each candy. It lost 1 euro. So this is the new price of the candy, which is the price I sold the candy or each candy with after 1 month has passed. Now, if this is the new price of each candy, it means that the new price of all candies is 6 multiplied by the new price of each candy. Now, how to evaluate this according to our previous set of rules? First of all, we need to perform the operations between parentheses. We have division and subtraction, so we calculate we perform the division first. So 6 stays out as it is. Then 18 divided by 6 gives us 3 minus 1. Now we still have the brackets, so we continue with the operations inside the brackets to get 6 multiplied by 2, and this gives us 12, which is the price I sold all candies with after 1 month has passed. Now consider the following expression: 3 plus 4 multiplied by 6 divided by 3 minus 10. Let's answer the following questions. If the intention of the writer of the expression was to subtract 3 from 10, what change would they need to do? We notice that normally if we ignore this question, if we wanted to calculate the value of the numerical expression, we multiply first and then we divide according to the set of the rules. After that, we perform the addition and the subtraction. However, now, maybe the writer has a certain problem and he is using this numerical expression as a model to this problem. And he needs, or she needs, to subtract 10 from 3, here 10 from 3, and he needs to do something to let the person who is finding the value of the expression to understand his intention, okay? So the only thing he has to do is to include 3 minus 10 between brackets. So by this way, we start performing the operation between the brackets first, then we move to perform the rest of operation using the set of rules for ordering operations that we learned on the previous slide. Now the second question, find the value of the expression as it is without the brackets. So the expression was 3 plus 4 multiplied by 6 divided by 3 minus 10. So we start performing the multiplication, then the division as we learned. So 3 stays as it is. We perform from left to right. Here the multiplication exists on the left side of the division. So 4 multiplied by 6, 24, divided by 3 minus 10. Now we have addition, division, and subtraction. The division takes priority over addition and subtraction. So we get 24 divided by 3 gives us 8 minus 10. Now we simply add and subtract from left to right. 3 plus 8, 11, minus 10. This gives us 1. And this is the unique value of this expression. Another test now. Find the value of the following numerical expressions. 24 divided by 4 multiplied by 2. Division and multiplication are of the same importance. They don't take priority over each other. However, according to the rules, we start with the operation that comes left. So here division comes before or left to the left side of the multiplication. So we start by dividing 24 by 4. This gives us 6 multiplied by 2, and the answer is 12. We move on to the second expression. We notice here we have multiplication, division, subtraction, and exponent. According to the set of rules, we start with finding the value of the exponents before the other operations. So we get 4 multiplied by 3 divided by 2 minus 4 to the power of 2 is 16. Now we have multiplication, division, and subtraction. So we start with the multiplication, then the division. So this gives us 12 divided by 2 minus 16. Now we have division and subtraction, and we know that division takes priority over subtraction. So we get 12 divided by 2 equals 6, minus 16, this gives us minus 10. Now, the last expression, between brackets, we have 3 multiplied by 4 to the power of 2 divided by 2, then close the bracket and add 8. This expression, we start performing the operations inside the brackets. So inside the brackets, we have multiplication, exponent, and division. We start with the exponent. 3 multiplied by 16, 4 to the power of 2 is 16, divided by 2. We close the bracket and we add 8. Now, we perform from left to right multiplication, because multiplication falls on the left side of the division. 3 multiplied by 16, 48, divided by 2, plus 8. This gives us 24 plus 8, which is 32. Thank you for watching.